When we come to write properties, we may think in our own minds we know what's required, but a lot of the time people kind of try and express too much in a property. What we're going to talk about now here is general versus specific properties and what information they actually yield. So the first kind of rule is don't add unnecessary detail because you find it's not required and it doesn't really help you learn anything more than you would have done by a more general property. If you add more detail into your properties, you run the risk of, especially if it's constraints, over constraining your system. You can increase the complexity of your properties, which makes it harder for the tool to prove. And the more detail in there, the more likely it is you make a mistake, not in the terms of a compiler error, but in terms of not expressing the kinds of behaviors you wanted to in the first instance. So these two properties shown here, now are not for one moment saying they're both equivalent, but they demonstrate an important point about this kind of really a frame of mind, a way of approaching a problem when thinking about a general versus specific property. So the first property, or let's say the property we actually wanted to write was this specific one. We had the specific behavior in mind because it was a functional requirement of the design and we wish to check it. So we should never see A, B and C true at any POS clock is our requirement. And we could go and draw up a truth table for this, all possible combinations of A, B and C, and we could observe under which conditions they pass and fail. But let's say, for example, this property, specific property, it does not achieve convergence, i.e. it takes too long to prove. What can we do next? One thing is just to say, well, never mind. It wasn't my intent to try and prove this property, but we can get further by thinking more closely about what are we actually interested in. So, this property specific may have come directly from the spec, almost the functional spec, and we may not have thought too much about it until now when we're faced with the situation we have an undetermined result and we need to know what to do next. So let's say to ourselves, okay, we analyze the cone of influence for this property and we observe that C has a very big fan-in. There's a lot of things contributing towards C which make it difficult for the formal tool to prove that property is true under all circumstances. So let's consider what would happen then if we remove C from the expression. And this is what we end up with at the property called general here. So we just remove the term C. Now if we were to draw out the truth table for this now, all combinations of A, B and C, for the general property, i.e. checking A and B is never true, they pass under all the same circumstances as the one we originally intended, except for this one case, except for the one case where A is 1, B is 1 and C is 0. Okay, so the next question to ask ourselves is that combination of A, B and C important? I.e. can it ever occur in our system by design or via constraints? And if the answer is no, it's not important to us, then as far as we're concerned, a pass of the general property is as good as a pass of the specific property. So this decision on whether it's good enough is a human decision because only you know whether the combination of A, B and C shown outlined here is actually important or not, functionally. Let's try and apply the same kind of thinking as the previous slide now to sequential properties. So what we've got here is two properties. The first one, let's say we looked at our functional specification and we saw a requirement for how inputs should behave in order to follow a specific protocol. So often a temptation is to try and write an assumption that completely defines the input behavior. So here we've got a long antecedent, which is a sequence, which implies next cycle that E is true. So that very well may describe the behavior as per the functional spec, but do we really need that kind of sequential expression in formal? As we've said, sequential constraints are particularly problematic in formal, because it gives a lot of complexity for the tool. So the next question is, do we really need to say all of that? So as these things are assumptions, what we think to ourselves is, well, assumptions are only there to exclude false counterexamples. So I don't actually need all of this detail. I can, let's say, experiment with this. So what we're saying here is, can we replace this entire left-hand side with just D? Obviously, these two properties are not equivalent now. Just like the previous example, we were not saying that these two things are equivalent, but is it enough to say if I have D, it implies E is true the next cycle? Does that exclude all false counterexamples? And if the example is yes, then it was good enough. We don't need all of this extra detail. If a property could fail, if the inputs were driven in a way described by this left-hand side sequence here, then the tool would find it. It doesn't need to be told how to find it. So again, we might find that our complexity is a lot less by actually removing detail from the property. And again, this is a human kind of decision as well. It's not like the tool can easily iteratively try out these things. It requires, the inventiveness of a human mind in order to know that what we've said here in this property general is good enough given what my requirements are, rather than fully expressing the complete behavior. So that was for an assumption. Let's try this same thing on an assert now. So again, the specific property we want to write, because that was a functional requirement, says if I have rec and not grant, what must follow the next cycle is a sequence C followed by D. So we look at this and we find, let's say, the specific property again, as per the first slide we saw. It's saying that the result cannot be achieved in a reasonable amount of time. So this is an undetermined property. And when we analyse the COI for this property, we find out that grant has a large fanning cone. There's a lot of complexity in working out when not grant's true. So what we can say instead is this general property. So essentially we've removed the term grant here. So what can we say then? We know these properties are not equivalent, they're saying two different things. But how does this relate to our end goals? So let's analyse this. If this property general passes, then would the other property pass? And the answer is clearly yes. So on this second property, the general one, we're not paying attention to anything grant's doing. So grant could either be 0 or it could be 1. So if the general property passes, then so does the specific. Grant was not needed in order to prove that property. Okay, so we might have saved ourselves a lot of effort there just by thinking of things in a slightly different way. So if it turns out that the general property fails, then it doesn't mean the top one will. We have to analyse further, so we might have to adapt our properties if we still have undetermined results from this one, or if we have excessive runtimes, or we get too many false negatives, i.e. failures when there should not be failures. So hopefully from this video what you've learned is that even though the requirements for the property may be completely unambiguous, then it still pays to think very deeply about what the property actually entails in terms of what the tool would need to check. Thanks for listening.